So which of the following scientists had a major contribution to the development of the modern periodic table? Okay, so here we have them. So it's not Newton or Einstein. Newton and Einstein were physics majors. They were influential in many fields, but these two generally influence physics more than anything else. And Newton also maths, so it's not these two. Now it's between Mendeleev and Chatelier, or Chatelier. So this guy here, Chatelier, was the developer of the equilibrium concept. So he didn't do much for the periodic table. So it was left to Mendeleev, who is the father of the periodic table, and he was our correct answer. Okay. So question 11, which of the following statements is false? So the ionization energy of the elements tends to decrease from left to right across a period. That sounds like it's wrong because you've got the lowest ionization energy on the left-hand side and the highest ionization on the right-hand side. So maybe A is wrong. So that could be our answer, but maybe we'll just check the other ones in case. The atomic radius of the elements tends to decrease from left to right across a period. That kind of sounds wrong as well, because as you go across, the atomic radius shouldn't get bigger because the atoms are getting bigger. So maybe B is wrong as well. So maybe we'll come back to that. The electronegativity of the elements tends to decrease down a group. That's true. So that can't be an answer, because remember we're looking at the false one. And the reactivity of metals tends to increase going down a group. Again, that's true, because the electrons are further away from the nucleus, so they're not as tightly bound, so they can be torn away very easily. So again, these can't be an answer because it's true, and we're looking for the false ones. So it's between these two now. Well, B, the atomic radius of the elements does actually decrease, with the exception of the noble gases. Let's just ignore the noble gases for now. But from when you go from the left-hand side to group 7 on the right-hand side, the atomic radius actually does decrease. So you might be asking why. Well, a period or a row of the periodic table tells you how many shells that atom has, okay? So if the black spot is our nucleus, let's say we're in period 2, where we've got 2 shells. As we go across the periodic table, the number of protons goes up. So we get lots of protons, okay? Lots of protons in here. But the number of shells stays the same, okay? So the number of shells out here stays the same. But the attractive force between the electrons out here and the protons gets bigger because there's more protons. So what it does is it tends to pull the electrons in a little bit. So the shell might actually just be in here. So the electrons actually get pulled closer to the nucleus. So you can see the radius actually goes down a little bit. Okay? So as you increase the number of protons, the radius drops a little bit. So B is actually true. The radius does go down as you go across the period. So that leaves A, which is the correct answer. The ionization energy doesn't decrease from left to right, it actually increases. You need more energy to remove electrons as you go across the group from left to right, the period from left to right. Which of the following best describes the atomic number of an element? Well, we won't go through each one because you know the atomic number is the number of protons, so we'll just look for that one. Number of protons? It's the only one with number of protons, so it must be C. So the number of protons in a neutral atom of the element. That's the atomic number, okay? You don't need to go through each one because we already know the definition of the atomic number. It's the number of protons in a neutral atom of the element.